Hi, and welcome to 6.1 Solving Linear Systems by Graphing. To start with, we should probably talk about what is a linear system. And A linear system is is two or more, usually just two, linear equations. And 6.1 is mostly done on graphing, and it's super numeric, and you don't really understand why you would want to solve a linear system. So to start with, I took an example that you do potentially later in the chapter, just to go over so that you can kind of see why. And I've typed most of it out so that we can get through it fairly quickly without having to think too much. So an end game example. Wile E. Coyote is trying to catch the Roadrunner. The Roadrunner has a 300-meter head start, and their movement can be modeled by the function d is equal to 30t plus 200. Don't worry too much about the numbers, but there's one equation that's linear. We can see that it's got a slope of 200 and a y-intercept, a slope of 30 and a y-intercept of 200. And here is our little let statement. D is the displacement and T is time. So those are the things that we were used to seeing from the previous section. Wile E. Coyote's bow arrow enhanced movement is modeled by D is equal to 40t. So there we have a slope, and we could add a plus 0. So our y-intercept is going to be 0. Assuming everything works out in Wile E's favor and normal physics law apply, when and where will Wile E catch the Roadrunner? So notice how our y-axis is going to be our displacement and our x-axis is going to be our time. So what we want to know is we want to know at what time will Wile E. Coyote's displacement be the same as the Roadrunner. I went ahead and plugged it in Desmos, and we're going to see if this works. So far, so good. I don't know why it's opening 4 tabs, but let's see, 6.1 example 1. We're off to a great start. And if it loads it, I'm going to turn those off for a second. And what I've done is I've played with the axes a little bit, so things are going to show up. And I've typed these in already. So d is equal to 300t plus 200, and this is the Roadrunner. Notice how at time is equal to 0, the Roadrunner's got that head start that we talked about. And then it just goes farther and farther away. And what we want to talk about is the Wile E. Coyote, who's now in blue. And we see how up here they intersect. So 20 is our x-coordinate, and y is 800. So remember we talked about x being time and y being displacement. So in 20 seconds, Wile E. Coyote and the Roadrunner will be in the exact same place at the exact same time, which means Wile E. Coyote would have got the Roadrunner. And all we did was graph those two and then find the intersection. And that's kind of what today's theme is going to be about. And that's why we would do it, is we can solve this system of two equations, this 30t plus 200 and this 40t, simultaneously. So that point, 2800, will work in both of those equations. If we go back one, I think we've got a little picture of our Wile E. Coyote with his bow and arrow contraption, and I think maybe just for funsies, I don't know why it does it twice, but we might be able to see what happens to Wile E. Coyote.
We get it. You don't
Oh,
really want your kids
ads.
watching videos, but it can have certain advantages.
Here we have Wile E. Coyote getting set up. Let's Roadrunner run past. So unfortunately, Wile E. Coyote did not catch up to the Roadrunner. Wasn't given the full 20 seconds to get there. So let's look at some examples. There's 3 different cases we can look at. Case 1 is one solution. this is the most typical. Two lines cross at one point. So for me, most of the time when I imagine two lines, this is kind of what happens eventually. They cross somewhere. And there we have an example of two lines crossing. This one is much like our Roadrunner example. These lines cross at 2, 5. No solutions is a little bit harder to see. No solutions, I'm going to bring up the calculator again. No solutions. See what happens if you have two lines that are parallel, so they will never cross. And I wanted to bring this up in Desmos. You can see just on the left here the equations that I've typed in. Notice how it's really easy to see they have the same slope but different y-intercepts, so they're not touching. And if I zoom, if I change my axes a little bit and I continue to zoom, no matter how far out we zoom, they will never, ever, ever meet. So they will never cross, and so that means they will end up with no solutions. And I think I have, if I did this right, also a little example like that of the one that we just talked about. No solution. Never at any point in time will those two lines cross. Infinite solutions. So I typed out 2 so you can look at them. Y is equal to 1/10 x plus 3. X minus 10y is equal to negative 30. Notice how that first equation is in slope-intercept form and that second equation is in standard form. And I don't know what they're going to look like if they're graphed. So if we open them up, and I just graph both of them using Desmos, which is a little bit of a cheat, but it gives us a really good idea. I just type them in exactly as they are. I'm going to turn them on one at a time. There is my red line. So my red line is that top one, y is equal to 1/10 x plus 3. And there is my blue line, x minus 10y is equal to negative 30. And notice how they are in the exact same spot. So since they're in the exact same spot, they are touching absolutely everywhere. That means there is an infinite number of solutions. I might actually just go down and write down a couple of notes in case someone can't hear me and actually has to read these over. So I will write down parallel lines will never touch. Therefore, the system has no solutions. In this one, if they're parallel and same y-intercept, so they're basically the same line, they will touch everywhere. And there is an infinite number of solutions. So I think it's worth noting while we're talking about this that, for example, the point 2, 1 isn't a solution to either of them. So it's not that every single pair of points is a solution. But this point here, say 0, 3, this y-intercept, is definitely a solution for both of them. Let's look at some examples. Example number 1, determine if the ordered pair is a solution to the linear system. So here we have 2 equations that make up our linear system, and here we have a point. And we want to know if the point works in this linear system. And what we're going to do is we're just going to plug these points in. So each ordered pair gives an x coordinate first, and then a y coordinate, and those are our 2 variables. And we've been doing this already with our word problems. What we want to do is we want to see if the left-hand side is equal to the right-hand side. So what I'm going to do is I'm going to make a little table. I've got on one side a 2x plus 3y, and on the other side 2. So I'm going to take my points and I'm going to plug them in. I've got a 2 times 2 plus 3 times negative 2. And this one, since I've got no variables, I can just write down 2. 2 times 2 is 4. Plus 3 times negative 2 is a negative 6. A 4 plus negative 6, I believe, is a negative 2. And then the right-hand side is a 2. Since the right-hand side or the left-hand side does not equal the right-hand side, this is not a solution. I'm going to go ahead and check the other one. I think when I made these up, I meant for it to be a solution, so I might have made a typo, but we can see anyway, it's still a good example. I've got y on the left-hand side of my second equation and a half x plus 3 on the right-hand side of the equation. So my y is going to be a negative 2, and on the right-hand side of the equation, x is going to be a half. X is 2 plus 3. Negative 2 is on the left-hand side. A half times 2 is 1 plus 3 is 4. Notice how negative 2 also does not equal 4. 2 negative 2 is not a solution to either one of those equations. Let's take a look at this second one. So we're going to do the same thing. We have our two equations and our point. And I'm going to take this number and I'm going to substitute it in. I've got my x value and my y value. I'm going to take it and I'm going to make my little chart again. I've got y on one side and I've got a 4x plus 3. And I suspect I've made a mistake and this one isn't going to be a solution either. I'd like to demonstrate one that was a solution, but all it means is that if one side is the same as the other side, then it is in fact a solution. But let's go ahead and check. Let's not get ahead of ourselves. So on my y is going to be 3, and on the right hand side I have a 4 times 0 plus 3. 4 times 0 is 0 plus 3. So this case 3 is equal to 3. Yes, 0, 3 is a solution for the first one. Is a solution. Let's check the other one. In order for this point to solve the system, it's got to work for both lines, not just one. So I've got a 3x plus 4y is equal to, sorry, I'm making a table, not a equals, 10. So on my right-hand side, I'm just going to drop that down. It's just going to stay 10. There's no variables over there. On my left-hand side, I have a 3 times x, which is 0, plus 4 times 3. And I end up with 3 times 0 is 0, plus 12. 12 does not equal 10, so this is not a solution either. 0, 3 is not a solution. Do I have a second one? Nope, that's it. Let's look at more examples. Okay, solve the following system by graphing. Step 1, rewrite the equations in slope-intercept form. Standard form is no fun to graph from. It is still possible, but it's a little bit tricky and involves some mental math if you want to do it efficiently. It's much easier just to transfer it into slope-intercept form. Step 2, graph each equation. Step 3, identify the solution, and last, do a double check. Substitute your solution back into your system. So I've got these all color-coded. I'm going to go ahead and start doing them. Rewrite the equations in slope-intercept form. I'm going to write small because I have a feeling it's going to be a big question. I didn't leave myself enough space to do it. X plus 2y is equal to negative 4. In order to get into slope-intercept form, I want to isolate y. So I'm going to subtract x from both sides. and I have a 2y is equal to negative 4 minus x, and I'm going to divide this side by 2 and this whole side by 2. Y is equal to, and then I'm going to split this fraction up, negative 4 over 2 minus x over 2. And what I'm going to do, just so it looks more like, keeping in mind that slope-intercept form, maybe I write that up here in red, y is equal to mx plus b. I want my x term to be first, and x over 2, negative x over 2, is the same as negative a half x. Notice how if I multiply that back out, I end up with the exact same thing. So y is equal to negative a half x. Negative 4 over 2 is a minus 2. So that's one of them. The other one looks a little bit easier. I have x minus y is equal to 5. I am going to, again, move the x over to the other side by subtracting it from both sides. Minus x. I end up with a negative y is equal to 5 minus x. Since this is a negative y, I want it to be positive. I can multiply it by negative 1, which means I have to multiply my right side by negative 1 as well. And I get y is equal to x minus 5. Notice how that negative 1 getting multiplied in makes that a positive x. Negative 1 multiplied into 5 makes it a negative 5. So I now have finished step 1. I've rewritten both of my equations in slope-intercept form. Next, I'm going to graph each equation. So let's call this guy 1. I'm going to do number 1, y is equal to half x, negative half x minus 2, which means I'm going to find my y-intercept, which is negative 2 right here, and then I'm going to do my slope. I go down 1 over 2, down 1 over 2, down 1 over 2. I'm going to do a bunch of these just because I strongly dislike my ruler tool. I can also go up 1, left 2, up 1, left 2, up 1, left. And it's going to look, I think I've made a mistake somewhere in there. There's points that don't end up on my line. So let's do there, up 1 over 2. There it is, up 1 over 2. And I'm just going to keep doing a bunch of those. Now I can draw my line. And see, it doesn't like, it kind of skips around. Let's try once more, and then other than that, I'll give up. Yep, and I'm going to have to go back to my ruler trick, which really didn't work that well. But it's very similar to your ruler. I just take a straight edge, I put it on my computer, I line it up with my dots, and you can see it's not a very good ruler. But it'll do the trick for now. I'll try and get a better one for next time. Let's do number 2. I'm going to do this one. Can I see gray? Well, nope, can't see gray well enough. I'm going to do this one in black as well. Number 2, my y-intercept is negative 5, so I go down to negative 5, and my slope is 1, so I go up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1, and I can go the other way as well. I can get my straight edge out. I'm randomly grabbing different things to use as my straight edge. Let's see if this one works better. Line it up with my dots. Oh, that works substantially better. Cool. Graph them both. 2 is done. Step 3, identify the solution. So my solution here is the point where they both cross. Right there. It looks like it's the point. My x value is 2. My y value is negative 3. So I could write down my final answer is 2, negative 3. And I could give it a box so people know. What I want to do is I want to make sure that this is a solution, so I can take this and I can substitute it back into either of my equations. So notice how in the red I've done a bunch of algebra, and I don't know if I've made a mistake there. My mistake could have been there, so it's not worth substituting it in there. What I'm going to do is I'm going to go back to my very original equations and see if 2, negative 3 is a solution. So I'm going to make my little table, x plus 2y and a negative 4. And I'm going to plug my 2 plus 2 times negative 3, negative 4 in. 2 times negative 3 is 5, or negative 5, or sorry, negative 6. 2 minus 6, -4, -4. Yes, that is a solution to that first equation. Let's look at this second equation, x minus y, 5. And I've got a 2, -3. So I've got a 2 minus -3. And on the right-hand side is going to be 5. 2 minus -3 is a 2 plus 3. 5 is 5. Yes, passes the double check as well. And I think that is the end of 6.1.
Thank you for watching, and I just wanted to remind you guys a couple of keys for success. Number one, you got to do the practice questions. If the things I'm saying make sense, that's phenomenal, but you still have to practice and make some mistakes on your own. That goes along with number two. If you get stuck, ask me questions, get in touch, write me an email, make an appointment, or leave a comment on the YouTube video. And step number three to success is look after yourself. Eat good food, get some exercise every day, and socialize as much as you can right now. I hope you guys are all doing well, and I will talk to you soon.